Good evening, and thank you for being here. Imagine you're looking at an image, and suddenly your mind starts to see things that aren't really there. Shapes shift, colors change, and reality seems to bend. Welcome to the fascinating world of optical illusions. These visual puzzles have been intriguing humans for centuries, captivating our senses and challenging our perception of reality. Tonight, we'll take you on a journey through some of the most mind-bending optical illusions and uncover the science behind how they trick your brain. Let's start with one of the classic illusions, the Müller-Lyer illusion. At first glance, it appears as if two lines of equal length are different. One line has arrowheads pointing inwards, while the other has arrowheads pointing outwards. Your brain, influenced by perspective cues and depth perception, is tricked into thinking the lines are different lengths. This illusion reveals how our brain processes spatial information and how context can alter our perception. For example, in everyday life, our brains use contextual information to judge the size and distance of objects. When you see a person standing next to a building, you instinctively understand the building is much larger, even though the person might appear taller if they were closer to you. The Müller-Lyer illusion exploits these interpretative habits, showing us that our perception of length can be easily manipulated by surrounding visual cues. Now, let's dive into the world of color illusions. Consider the famous checker shadow illusion by Edward Adelson. In this illusion, a checkerboard pattern is shown with a shadow cast over it. Two squares, one in the shadow and one outside of it, appear to be different shades of gray. But hold on, there's more to uncover. When you isolate the squares, you realize they are actually the same color. Our brain takes into account the surrounding context and lighting conditions, leading us to perceive different colors even when they are identical. This phenomenon occurs because our visual system is constantly trying to maintain color constancy, which helps us recognize colors under varying lighting conditions. For example, a white piece of paper looks white whether you're outside in bright sunlight or indoors under dim lighting. The checker shadow illusion demonstrates how powerful contextual information is in shaping our perception of color. Moving on to motion illusions, have you ever seen a still image that seems to move? The rotating snakes illusion by Akiyoshi Kitaoka is a perfect example. This static image appears to have rotating circles. The secret lies in the arrangement of colors and shapes, which create small eye movements that trick your brain into perceiving motion. This phenomenon demonstrates how our visual system interprets movement and can be deceived by certain patterns. Another example is the rotating wheel illusion, where a spoked wheel appears to rotate backward when it is filmed and played back at a certain speed. This happens because our brains can be confused by the strobe-like effect of the spokes, causing a misinterpretation of the actual direction of movement. Now, let's explore the phenomenon of ambiguous images. The famous Rubin's vase illusion presents a black and white image that can be seen either as a vase or as two faces in profile. Your brain switches between the two interpretations because it can't decide which part of the image is the foreground and which is the background. This type of illusion highlights the brain's ability to create multiple interpretations of a single visual stimulus and how our perception can be fluid. Another classic example is the duck-rabbit illusion, where a simple drawing can be seen either as a duck or a rabbit, depending on your perspective. These illusions illustrate how our brains can switch between different interpretations of the same image, demonstrating the flexibility and ambiguity of visual perception. Another fascinating illusion is the Ames Room, a distorted room that appears normal when viewed from a specific angle. In this room, people can appear to grow or shrink as they move from one corner to another. The clever use of angles, perspectives, and distorted shapes tricks the brain into believing the room is a regular rectangle, demonstrating how our brain relies on visual cues to judge size and distance. For instance, if you visit an Ames Room exhibit, you might see a person who looks significantly taller than another person standing just a few feet away, even though both are actually the same height. This illusion plays on our brain's assumptions about the geometry of rooms, showing how easily our perceptions can be distorted by altering visual contexts. But hold on, there's more to uncover. Optical illusions not only entertain and amaze, but also offer valuable insights into how our brain processes visual information. Neuroscientists study these illusions to understand the complex mechanisms behind perception, helping us learn more about how the brain works. These insights can have practical applications, from improving visual displays to aiding in the diagnosis of visual and neurological disorders. For example, understanding how our brains process motion can help engineers design better virtual reality systems that minimize motion sickness. Additionally, studying color illusions can lead to better color correction algorithms in photography and filmmaking, ensuring more accurate color reproduction. As we wrap up our journey through the world of optical illusions, remember that these visual puzzles reveal the incredible complexity and adaptability of our brains. They show us that what we see is not always what we get, and our perception of reality can be easily influenced by context, lighting, and perspective. The next time you encounter an optical illusion, take a moment to appreciate the intricate workings of your brain that allow you to experience such fascinating phenomena. Thank you for joining us on this captivating exploration of optical illusions. We hope you've enjoyed unraveling the science behind these mind-bending tricks and gained a deeper appreciation for the mysteries of human perception.